In this slide, we will be discussing about the complete graph. What is a complete graph? A graph in which V node is adjacent to all other nodes present in the graph is known as a complete graph. There are two types of complete graph. One is directed complete graph and another is undirected complete graph. We already have discussed about what is directed graph and what is undirected graph. The graph with directed edges is known as directed graph, whereas the graph with undirected edges is known as undirected graph. So what is undirected complete graph? A undirected complete graph contains the edges, that is n into n minus 1 divided by 2, where n is the number of vertices present in the graph. So the directed complete graph are the graph in which the number of edges in a complete graph with n vertices is n into n minus 1. So here we can see the diagram of complete undirected graph and the diagram of complete directed graph. Here the edges are directed, whereas here the edges are not directed. At the very last part, we will be discussing about the topic that is representation of graph in memory. So it is represented in basically three ways, that is adjacency list, adjacency matrix, and incidence matrix. The vertices are stored as records or objects, and every vertex stores a list of adjacent vertices. This data structure allows the storage of additional data on the vertices. The additional data can be stored if the edges are also stored as objects, in which case each vertex stores its incident edges and each edge stores its incident vertices. At the next, we have adjacency matrix, a two-dimensional matrix in which the rows represent source of vertices and columns that represent destination vertices. The data on edges and vertices must be stored externally. Only the cost of one edge can be stored between each pair of vertices. At the last, we have incidence matrix, two-dimensional Boolean matrix in which the rows represent the vertices and columns represent the edges. The entities indicates whether the vertices at a row is incident to the edge at a column. So this is the end to our graph chapter. I think this would be really helpful to you. Thank you.